Hello everyone! Have you ever struggled with debugging in Unreal Engine? Tired of constantly adding print strings to the screen? Frustrated with having to repackage your game every time you need to test a small change? Or maybe you've struggled with debugging on mobile devices, where tapping in console commands one letter at a time is a slow and painful process. Well, what if I told you there's a better way? Today, I'm excited to introduce Runtime Details, a powerful Unreal Engine plugin that lets you debug and modify your game in real time, across all platforms, without ever leaving the editor. Runtime Details creates a bridge between your running game and the Unreal editor. It launches a server in the editor that can connect to any client, whether it's a packaged build for PC, Android, iOS, or even another editor instance. Once connected, you can inspect, modify, and interact with any UObject in your game as if you were running in the editor itself. Now, let me show you exactly how it works with a practical demonstration. Let's start by getting our game client connected to the editor. First, I already have my packaged Windows game running independently. As you can see, it's a standalone executable, completely separate from the editor. Now, over in the Unreal editor, I need to open the Runtime Details window. With the window open, the plugin has automatically started a server in the background. The key piece of information I need is right here, in the server address field. It shows me the local IP address and the port that the server is running on. This will be different depending on your network. Inside the game, I'll open the console and type the Runtime Details Connect command, RTD, connect, and press enter. The command executes, and if I look back at the Runtime Details window in the editor, my game client appears right here in the clients list. You can see its IP address and that it's successfully connected. The client will start automatically sending object data to the server, and we're ready to start inspecting and modifying the game in real time. Over here in the object list, you can see a list of all the UObjects that are being tracked from the connected client. The list is constantly updating. I can just click on different objects in this list. All of its properties populate the Details panel on the right. This immediate feedback is the foundation. It confirms that we have a solid real-time pipeline from the game client to our editor tool. In the next steps, we'll start actually changing these values and see the game react. Now, we're going to change both the model and the material of a cube. First, I need to find a cube in the object list. Here it is. Now, in the Properties panel, I can see its components. I'm looking for the static mesh component because that's what holds the visual mesh and materials. Let me click on that to select it. Now on the right, I'm seeing all the properties of this static mesh component. I need to find the static mesh property. Here it is. To change it, I just click this little button right next to the property value. It opens the asset picker, just like in the regular editor. Let me pick a different mesh. Look at that. The mesh has been changed in the game. No compilation, no restart. The change happened over the network. Next, let's change its material. I'll switch to the Function tab here in the Runtime Details window. This lists all the available functions we can call on this specific component. I'm looking for the setMaterial function. Here it is. I'll click on it. It gives me an interface to execute the function. Let's pick a material and then I'll simply click the call button. The material on the mesh in the game is instantly swapped. Now, let's try to move an object. This next demo is particularly important because it shows you how to troubleshoot when things don't go as planned using the powerful remote log feature. Let's find another cube and select its static mesh component. Now, I'm going to try to lift it into the air by modifying its relative location. I will find the Z value and change it. Nothing happened. The cube didn't move. In a traditional debugging scenario, this would be frustrating and you'd be left guessing. But with Runtime Details, we have immediate insight. Let me switch over to the Remote Log tab. As you can see, while I was making that change, the client captured all the relevant log messages and sent them back here. Look at this warning from the engine. It says we can't move a static mesh component without mobility set to movable. That's the issue. The component's mobility is currently set to static, which means it can't be moved at runtime. So, let's fix that. I'll go back to the Properties panel for this component and find the mobility property. I'll click on it and change it from static to movable. Now, let's try moving it again. I'll go back to change the relative location and watch this. The cube instantly teleports to the new height and then falls down. Up until now, we've been modifying actors and components, but Runtime Details can do much more. It can inspect and modify any UObject in the runtime, which is incredibly powerful for debugging. Let me show you by working with Material Instance Dynamics. Right now, my object list is cluttered with all sorts of actors. To find what I need, I'll use this type filter combo box. I'm going to click it and select Material Instance Dynamic from the list. Instantly, the list now only shows the Material Instance Dynamic objects present in the game. This is perfect for when you need to target something very specific. I can see my character's materials in here. Let me select one. Now, with this mid selected, I'll switch to the Functions tab. I'm looking for a function called setTextureParameterValue, which allows me to dynamically swap a texture on this material. I need to provide the parameters. For parameter name, I'll type in base texture. That's the name of the texture parameter I want to change in my material. Next, I need to assign a new texture. Alright, everything is set. Now, I'll hit call function, and the character's base texture has been instantly replaced in real time, giving it a completely new look. Now, let's move beyond modifying properties and into directly controlling gameplay logic. We're going to find our main character blueprint and force it to perform an action by triggering one of its events. I'll use the type filter, select BP third-person character from the list. Now, with the character selected, I'll switch to the Functions tab. This is a key point. In Unreal, a blueprint's events and custom functions are exposed as UFunctions, meaning they all appear right here in this list. I'm looking for the jump event, and then press the call function button, and the character immediately performed a jump action. Now for our final demonstration, remote console commands. This is especially useful on mobile devices, where typing commands is a major hassle. Instead of trying to type complex commands on a touch screen, we can execute them directly from the editor. To do this, I'll use the type filter again. This time, I'm going to search for a core engine class called Kismet System Library. I'll go to the Functions tab and find the function named Execute Console command. This function allows us to run any console command as if we had typed it in the game's console. I'll click on it. Now, in the parameters, I need to provide the command I want to run. Let's start with something visual. I'll type statgame. This method completely bypasses the need for a physical keyboard on the device. Whether you're testing on a phone, tablet, or any other device, you have full control over the game's console, making advanced debugging and profiling accessible everywhere. And there you have it! With the Runtime Details plugin, we've moved far beyond just printing to the screen. Now, you can instantly tweak values, test functions, execute commands, and diagnose issues, all in real time, without a single repackage. Thank you for watching! We hope this tool empowers you to build and debug your Unreal projects faster than ever before.